All right, in section 13, we're trying to figure out solutions to three variable systems. So what we're trying to figure out is we're trying to figure out an x, a y, and a z, where if I plug them in these three equations, they will all be true. So I plug them in the first one on the left side, it gives me 6, and then 3, and then 3. So there are a couple ways we can do this. One method is elimination, and one method is substitution. And I'll do this one problem both ways. So what I'm going to do is I'm going to label these equations 1, 2, and 3. So the first idea is I'm going to pick two equations and I'm going to try to eliminate any variable. So for example, if I pick equations 1 and 2, well, that would be x plus 2y plus z equals 6, and 2x plus y minus z equals 3. Now the reason I picked this one is I want one of the variables to eliminate. And if you look here, z and negative z will cancel out. So if I add these two together, I'll get 3x plus 3y equals 9. So we'll just kind of keep that to the side now, but we have 3x plus 3y equals 9. That has two variables, which is better than what we started with when we had three variables. So that's the first step. So now we're going to take two other equations. I'll take 2 and 3, but it doesn't matter. I picked 1 and 2 first, so I could pick 1 and 3 or 2 and 3. I just went ahead and picked 2 and 3. So now I want to eliminate the same variable. So in the first equation, I eliminated z because it kind of canceled out really nicely. In this one, the z does not cancel out quite as nicely. Actually, it would be really, really easy to eliminate the y. But we can't do that because we have to eliminate the same variable. So what I do see is I have 2z down here. What I'd like is negative 2z. So if I multiply everything in this one by 2, I'll get 4x plus 2y minus 2z equals 6. Very important to multiply everything by that 2. And then the second equation can just stay the same. 3x minus y plus 2z equals 3. But now if I add them together, you'll see I get 7x plus 1y equals 9. So I get a second equation that has two variables. So now I have these two equations that I found. I'm going to try to solve those simultaneously by elimination. So I have 3x plus 3y equals 9. And then I have 7x plus 1y equals 9. So I'm going to multiply this bottom one by negative 3 because I'm just going to eliminate the y. Once I've eliminated one of the variables twice, I should get a two-variable equation where I can just eliminate x or y or whatever the variable is. So this one will stay 3x plus 3y equals 9. This will become negative 21x minus 3y equals minus 27. So that is going to give me, these will eliminate, that's going to give me negative 18x if I add them. And again, I'm just adding straight down. And then 9 minus 27, or 9 plus a negative 27 is negative 18. So x is 1. So x is 1 is my first solution. Now, that's only part of the solution. We still have to find the y and the z. But now I'll just kind of go backwards. I'll just kind of back plug in. So I have two equations here that have x and y, but I know that x is 1. So if I just take one of those, maybe I'll take this guy here. Then I know 3 times 1 plus 3y has to equal 9. So 3 plus 3y equals 9. I'll subtract 3, so 3y equals 6. So y equals 2. So now I know x equals 1 and y equals 2. Now I have to find z, and then I'll be all done with the problem. Now, I don't really have anything over here for z, but I can go back to one of my original. Let's say I go back to this one. Well, now I can plug in x and y and get z. So 1 plus 2 times 2 plus z equals 6. So that's 5 plus z equals 6, so z is, of course, 1. Now, I obviously made this one pretty nice, so it worked out pretty nicely. 1, 2, and 1. And so you can go ahead and plug those into all three equations, and you should get correct equations for each one, true statements for each one. There's a lot to it. You got to eliminate one variable, then take the resulting equations, eliminate another, and then you just kind of plug back in. So that's one method, that's elimination. There is another method of substitution, and we'll just do this same problem with substitution, just to see which method you might like better. Okay, the other method is substitution. Now we know what the answer should be because we figured it out with a different method, but we can do it this way. So in this one, what we're going to do is we're going to find one equation and we're going to get one of the variables by itself. Doesn't matter which one. I'll pick the second one. I'm not sure why. 2x plus y minus z equals 3. And I'll just get z by itself. So I will subtract the 3 to one side, move it over here, and I'll move the z to the right. So I get z equals 2x plus y minus 3. So now the idea is I'm going to plug this in, because I have z by itself. I'm going to take 2x plus y minus 3, and I'm going to plug it in for z in the other two equations. Okay? Now, this is fine, and then some people do a hybrid method, so I'll show you what I mean when I do this. So when I do this substitution will get rid of the z variable. So in the first equation, I'll get x plus 2y plus z, but z is now 2x plus y minus 3 equals 6. And so if I clean that up, I'll get 3x plus 3y minus 3 equals 6, which is 3x plus 3y equals 9. And if you remember from the previous problem we did, we had this equation at one point, not surprisingly. And so for this bottom one, if I plug in, we get 3x minus y plus 2 times all this plus 2x plus y minus 3 equals 3. So this will be 3x minus y plus 4x plus 2y minus 6 equals 3. And so if I clean this up, 3x and 4x, so this and this, is 7x. 2y and negative y is positive 1y. And then we have this minus 6, which we can move over to the other side, which would be 9. And now we have these two equations. And not surprisingly, these are the exact same two equations we had on the previous page. Now, we could do elimination like we did before. We could also do substitution. We substituted here for one variable and plugged it in. We could do the same here. Easiest would be this one. Y equals 9 minus 7x, and plug that in over here. So we get 3x plus 3 times 9 minus 7x equals 9. 3x plus 27 minus 21x equals 9. So that's negative 18x plus 27 equals 9. This is almost an identical equation. It just looks a little different. Subtract 27. So negative 18x equals negative 18. So x equals 1. So we get the same x, just a little different way. So if you like substitution better, that's fine. I will say in some problems, substitution, the one problem is if you don't have nice ones to get a variable by itself, you'll definitely end up with some fractions. Now, we're of course not done. We'd have to plug in and figure out what y is and x is, but that's going to be just the same as the last one. So hopefully this gives you a couple ways to go with these kind of problems, and obviously if you still have trouble with them, let me know.